In the last video, I mentioned that there are several different ways to calculate the determinant of a matrix. Today we're going to look at the diagonals method, which is a very convenient method for calculating the determinant of the third order, meaning a determinant of a 3x3 matrix. It's very visual, so we will represent it using diagonals by taking the first two columns of our matrix M and writing them right next to the last column of matrix M, so A, D, G, B, E, and H. You'll see in just a second why this was necessary, so let's now use our highlighter to highlight the terms, and the first diagonal, which is going to be the positive diagonal, the second and the third, and we have our negative diagonals, first, second, and third. Now you see it looks very nice and symmetrical, so the terms highlighted in red are going to be positive and highlighted in blue are negative. And what we do is we multiply each diagonal, every term in each diagonal, and we add them together to get our final answer. Now with matrix M in particular, this is going to look like this. It's going to be AEI plus BFG plus CDH, and now we subtract our negative terms, minus CEG minus AFH and minus BDI. And that gives us the determinant of matrix M. Now let's look at another matrix that we can actually calculate. And we have matrix A over here, which is just different variations of 3, 2, 1, as you can see. So let's start by writing the first two columns next to our last column. 3, 1, 1, 2, 3, 2. And again, we can highlight the diagonals. So we're going to have the first diagonal, which is just all three. Then we have 2, 2, 1 as the second diagonal, 1, 1, 2 as the third positive diagonal. And our negative diagonals are 1, 3, 1, 3, 2, 2, and 2, 1, 3. So let's multiply the diagonals and we add or subtract them. Now the first one is obviously going to be just 3 to the power of 3, or 27. The second positive diagonal is 4. The third positive diagonal is 2. And now we have our negatives. So the first one is negative 3. And then the second is negative 12. The third one is negative 6. So what does that leave us with? We have 31, 33 minus 15 and minus 21. And that gives us the determinant of 12. And voila, this is our answer. And I encourage you to actually calculate this with the method we used in the previous video, just so that you can verify that I'm not lying to you and it's actually 12. And whether or not it's more convenient than the method we used previously is up to debate. It's obviously very limited in its scope, but to me it seems more convenient if we calculate it with the diagonals method, than with the method of multiplying the minors, since it's just more straightforward, it's less calculation. However, for any matrix that's bigger than a 3x3 matrix, obviously you will have to either use the method we've outlined before, or a different method, but those two I believe are the most commonly used.
Now that you understand the basic concepts, you're ready for more advanced topics. Do not forget to subscribe, and we'll see you in the next video.